Good morning, everyone. My name is Akmal Rustamov. My PhD supervisor is Fabio Dois. Today, for the poster day, I would like to present implementation and resilience tense of GNSS positioning system of the road application. It is short outline for today's presentation. First, I'm going to discuss research scenario and motivation. Then I'm going to discuss research question and problems. Then we will see with you novel contributions of the thesis work, then preliminary results, and after that I'm going to finish with a conclusion. Does spoofing exist? Number of spoofing related cases increased in the world last years. Spoofing also becoming very easier because of the using open source softwares and very cheap hardware available. Spoofing is very fun, but we have to know it's illegal and it must be performed only in controlled conditions. Also, we have to take into account that spoofing needs a lot of knowledge and safe conditions. All connected GNSS receivers are prone to different domain of attacks. The first signal level domain, such as RF spoofings, measurement level domain, and data spoofing. In these attacks, conceived to hijack network-based applications such as DGNSS and related applications. Connected receivers allow for data and measurement comparison from nearby or different locations. In our study, possible scenario and metrics are checked to identify resilience of positioning and navigation systems in mass-market connected devices to malicious attacks. The novelty of this work is developing anti-spoofing techniques for spoofing attacks and the portable spoofer. As you can see in the scheme, it's shown the low-cost portable spoof developed by us, and it works in the following the signal model, which is denoted in the below. So this schematic consists of three main parts, which is battery pack, Raspberry Pi, and Hack RF1. The front-end Hack RF1 is in charge to perform digital to analog conversion, mixing the baseband signal to the carrier frequency, thus offering quadrature in modulation in L1 band. Two types of data collection have been made. We can see the first one with the independent devices with the idea of comparing their data with the network communication. As you can see on the picture top right, two different kind of Android application use it. First one is GNSS logger and the caps lock. In order to download time interference and AGC carrier to noise ratio, and also downloading data from the jamming and multipass effects. Second data was collected with the simulated corporative scenario with the use of IFAN signals generator in order to foresee the processing of realistic RF signals through GNSS full software receiver. We can see the experimental setup. In the figure 1 on the right side, we can see the realistic scheme of the spoofing effect, which is used with Hack RF1, different kind of smartphones, and U-blocks for cross-validation. And the left side, we can see the schematic of this test on the static Android smartphones. The portable spoofer sprayed fake signals to target and agent victim receivers and changed their time and PVT solutions. Here we can see the effect of spoofing interference on the U-blocks the receiver. It can be seen that receiver has no defense against the simplistic spoofing attack with the latitude, longitude, and altitude changing during the spoofed coordinates, and hence validating the spoofing mechanism employed on the regular COTS devices. And you can see that all the latitude and longitude changed during the spoofing time from the figure. Here we can see the spoofing attack to the Earth-centered Earth-fixed coordinates on the left side, and in the right side we can see the number of satellites changing over the time during the spoofing time. The figure shows error position and Earth-centered Earth-fixed coordinates on the three different smartphones during the test, and we can see that the one smartphone is totally dramatically changed their the coordinate during the spoofing time, and the spoofing time span is delayed compared to previous plots as Enemy Tools app was initialized before GNSS Logger app. In this two plot analyzed AGC and carrier to noise ratio to different smartphones with spoofing and without spoofing conditions. On the top we can see the AGC with spoofing and without spoofing condition. On the left side and the bottom we can see the carrier to noise comparison under the spoofing attack and without the spoofing attack. And it's observed that the effect of turning the spoofer is similar what jamming interference with the due to presence of powerful spoofing signals, the receiver reduces amplification of incoming signal, which while disturbing real signals allows fake signals to be easily acquired. And the spoofer acts as a source of interference over the L1 frequency band. The effect is seen in the L1 signals under constellation as well. This slide represents one of the mechanisms of anti-spoofing techniques with AGC to carrier to ratio. On the top left, we can see the carrier to AGC to carrier to ratio and the spoofing attack. And the left, we can see that without spoofing attack. On the bottom left side, under jamming, and on the bottom right side, the multiphase effect. So from the results, we can say that across the different smartphones, slightly different levels of AGC to carrier to are observed depending on the front end. And it's possible to draw a threshold that will allow us to discriminate between jamming events and spoofing attacks. The threshold considering either the direct value or its change with respect to time between the different the pure ends, it's to be presented in the future work. In this slide, we can see the results of short-time measuring attack DGNS-SCP simulated scenario in the measurement level attack. So we can see that from the plot, the almost effect at PVT level. A distortion of the estimated trajectory is observed when measuring effect on the corporate framework. The altered trajectory can be slightly different from the true one. Here, the proposed attack detection can be the agent A has to perform the standalone incorporated PVT in parallel to implement attack detection at PVT level. By checking measurements from different aiding agents, outlier inducting distorted PVT can be detected. Performed a set of experimental tests and presented analysis toward devising anti-spoofing strategy in connected GNSS devices. With two synchronized devices in corporate framework, it's possible to metric and highlight and identify the spoofing attack. The different approaches on the attack to the framework are laid down in anomalies to be considered detect in attack in network cooperating device are presented. This presentation is a part of the larger goal to develop anti-spoofing detection and coping mechanism in connected COT devices. In the future, we will show the better analysis. In this slide, list of publications published since now and the hours of learning activities has been presented. Thank you very much.